Welcome to Unit 2. In Unit 2, we're going to jump into graphing sine and cosine function as well as other trig functions and start working with some trig identities. So it's all going to be trig. Okay. So at this point, we have at least seen the unit circle. Now we're going to get comfortable graphing different parts of the unit circle on a graph. Okay. Let's go ahead and start with the sine function. Whoops, sorry. Having issues with my iPad today. We're going to go ahead and start with the sine function. This is what the sine function is going to look like, right? It's going to have a hill, so it's going to have a peak right here, and it's going to have a valley, and then it's going to come back here. Okay, so this is really one iteration from here to here, starting and stopping. So 0 to 2 pi. Okay. There's a couple bits of information up top. We start at 0, 0. We finish at 2 pi and 0. We hit the axis again at pi 0. And then halfway between each, we have our max and our min at pi over 2, 1 and 3 pi over 2, -1, which makes sense if you think about the unit circle. Those are going to be those quadrantal angles. So all the things that are plotted right here at 0, pi over 2, pi, 3 pi over 2, and 2 pi are your quadrantal angles. And then these other dots here are going to be for your 30 and 60 degrees. Okay. All right. Some properties of the sine function. Um, let's talk about those. It's going to repeat itself every time you reach 2 pi, it's going to repeat. So the interval in this case is 0 to 2 pi. Oops, got ahead of myself. 0 to 2 pi. Okay, and that is one full cycle of sine. Just like on the physical circle itself, one loop is from 0 to 2 pi. Okay, sine x is an odd function. We talked about that in the last unit. That means it is symmetric across the origin. Its domain is all real numbers or negative infinity to infinity, right? Or we can use that symbol. And its range is going to be -1 to 1. And these are all for just sine of x. Once we start transforming it, those things are obviously going to change. Okay. Now let's take a look at this next example. Determine whether f of x equals sine of x has a maximum or a minimum at x equals -11 pi over 2. Okay, so essentially what we need to do is figure out the coterminal angle between 0 and 2 pi. Okay, since that is negative, I'll go ahead and add 2 pi as many times as I need. In this case, 3 times. Okay, so we're going to have -11 pi over 2 plus common denominator of 2. So 12 pi, and we get pi over 2. Okay, that is what we can reference if we're looking for a max or a min. Okay, sine is going to have a maximum at this value. If you remember on the unit circle, that's going to be right here. And so we're going to have a maximum value. Okay, let's briefly switch over to cosine. A lot of similarities are going to be visible. The only big difference is that our curve starts at its maximum and finishes at its maximum. It hits its minimum in the middle. It will touch 0 twice on the y-axis, okay? And it is important to note that we are not starting at 0, 0, okay? We are starting at our maximum. The period is still going to be 0 to 2 pi, okay? And also, let me jump back really quick. All of these points that we noted earlier are now different, but the intervals are still the same. It's still at 0, pi, and 2 pi. It's still at pi over 2 and 3 pi over 2, right? The y values have simply changed. All right. Cosine is even. That means it is symmetric across the y-axis. The domain is the same as sines. It's negative infinity to positive infinity. And the range is also the same, -1 to 1. Okay. Now let's determine if cosine of x has a maximum or a minimum at 7 pi. That means I'm going to have to subtract 2 pi several times. In this case, I know I'm going to have to do a subtraction 3 times. So 7 pi minus 6 pi is equal to pi. I know on the unit circle that pi is right here. And so thinking about cosine, cosine is going to be a -1 here. My sine value is 0. So I'm going to have a minimum. All right. Moving on to the next page. This right here, this generic equation will guide you in finding any equation of a sine or cosine function, as well as any transformation. Okay. I personally have always written it slightly different. I use A, B, C, and D instead of HK, but we use HK in this book, so we're going to use HK. Okay. So A is going to be what we call your amplitude. Okay. It is your vertical stretch. It's your vertical stretch. So that just means your curve is going to elongate. B is your period change. Okay. Um, it's also known as a horizontal compression. I like to write it as how many cycles do we have? Okay. So how many full cycles do you have from 0 to 2 pi? Horizontal shift or the phase shift. Okay. That's going to be moving left or right. Okay, horizontal movement, and then K is going to be our vertical shift. Okay. And F is really just sine or cosine, so you could replace it with either. The one other thing worth noting is that it could be positive or negative. A negative will be a reflection over the x-axis. Okay, so that'll be important. All right. If you want to take a look at this link on Desmos, feel free. I'm going to go ahead and move into this figure. So if you look at this purple one, you'll notice that the period is, or sorry, B says 4. Okay, so B here is 4, which means you want to have 4 full cycles. So 4 cycles. Okay, whereas here we just have 1, so 1 cycle. And these cycles are between 0 and 360 degrees. Or 0 and 2 pi. So notice we start at 0, we finish at 2 pi. Okay, notice on this purple one, what's happening is you have a full cycle once, twice, a third time, and a fourth time. Okay, so that is where the 4 comes in. You are repeating 4 times. Okay, and mathematically, the period of a sine function is always going to be 2 pi divided by b, right? In this case, we had 4. So in this example, we had 2 pi divided by 4, which means we repeat a cycle every pi over 2 distance. So 1 cycle every pi over 2. Okay, 1 cycle every pi over 2, which if we were to draw kind of a line showing that separation, we'll see there's pi over 2, here's another pi over 2, here's another pi over 2. Okay, that's going to create those 4 sections, 4 total cycles from 0 to 2 pi. That is always going to be how you calculate your period. So make sure to commit that to memory. All right. Find the period of Denver's average temperature throughout the year using this sinusoidal temperature model. Okay. So we have 24 cosine of pi times m minus 7 over 6, all plus 50. Okay. The period, as a reminder, is going to be 2 pi divided by b. Okay. Our b, if we take a look at it, is going to be your pi over 6. So I am going to take 2 over pi over 6. Okay. That's going to turn into 2 pi times 6 over pi, which is going to equal 12. Okay. So my period is going to be 12. Okay. Now, just to touch back on some of the other things we just talked about, 24 is going to be your amplitude. So we're stretching by a factor of 24. 50 is going to be a vertical shift. So we're going up 50. And 7 is going to be a horizontal shift to the right. Okay. Horizontal shift to the right. Moving on. Vertical transformations. We are going to take each of those letters that we just talked about and show how all of them relate to a transformation. Let's start with vertical. Okay. The midline, or K, is the center of the curve. Okay. So it should be the same distance above there that is below. Okay. So in this purple curve that we have on the bottom of the page, we have a midline of 3. We have a midline of 3. That really just means you moved the function up 3 units. This is telling you we moved up 3 units. We moved up 3 units, right? Here was the 0, here is the 3. So everything moved up. Whoops. We also happened to stretch. Now, we don't love that we combine these, but we did also stretch. So our function started at a height of 1. It stretched to a height of 2.4, and then we moved it up. So if we wanted to show what that would look like before, it would be here. It would be there, and then we moved up those 3 units. From here to here, that is up 3 units. Okay. You can continue that curve all the way to 2 pi. And then if we look at our range is going to be K plus and minus A. So K is that 3 that we had. We had 3 plus and minus A, which was 2.4. Okay, that is your range, the lowest and the highest values. Lowest and the highest value. We're going to end up with 0.6 all the way up to 5.4. That is going to be your range. Same applies to cosine. So in this case, if we want the range of cosine, we are going to take our y value at the end, that -8 or that midline, and your amplitude, and repeat that process. K plus or minus A. So -8, oops, sorry. -8 plus minus 34. So we end up with a range of -42 all the way up to 26. Now, I tend to do this visually. There are obviously scenarios like this example where visually might not be the right choice. Ideally, for the problems that we're doing, the numbers are small enough to where it's easily graphable and you can just kind of see visually what the minimum and the maximum are, but the equation will always be there for you. Now, phase shift is when we move left or right. Okay, left or right. It is important to note that we are moving left if it is x plus something, and we are moving right if we have x minus something. Okay, that is going to be important. So the graph of sine of x is a phase shift of cosine of x. What is that phase shift? Okay, it's going to be pi over 2. The reason it's pi over 2 is if we were to graph these, sine is going to look something like this. Cosine is going to look something like this. Oh, actually, I'm going to use a different color. Da, da, da. Okay. Now, if I were to move this, right here they overlapped. What happens if I move it slightly? Notice what's happening when I move it. Okay. It is shifting by a single quadrant, which is the equivalent of 90 degrees or pi over 2. Okay. So it is a phase shift of pi over 2. It also works the other way, but this one is faster. Okay. It is just a phase shift. So slide that back over. Let's find the phase shift of the temperature model from earlier. Okay. Easy breezy. We mentioned that it was that -7, so 7 units to the right. 7 units to the right. Okay. Now that we've kind of talked about what all of them do, right? All of those letters, let's briefly find the equation of each graph function just to practice. I immediately noted this is a sine function. Okay. I notice that it looks to be stretching, so I know that this is an amplitude. So the function is 2 sine of x, right? 2 is multiplying by everything, which is why the zeros stay the same, but the ones increase to a 2 because 1 times 2 is 2. And my next one, I immediately notice I have multiple cycles. That suggests to me I'm changing my period. Okay. I also know this is sine, and I have 2 periods, so I have sine of 2x. Notice that my maximum and my minimum have not changed. The only thing that has changed is the number of cycles. On this next one, it looks like I have a phase shift. I am moving to the right, so I immediately know that I'm subtracting something. I know that this is still a sine function because I have a hill and then a valley. So I know I have sine of x minus something. I am moving pi over 2 to the right. So I know that I am subtracting pi over 2. Finally, I'm noticing that everything has shifted up by 2 units. So my midline is at y equals 2. I also recognize this is still a sine function. And so I'm just going to add 2 at the end to move all my points upward. Let's go to the next page. I immediately notice that this curve looks different. This looks like a cosine curve. Okay. I notice that I'm touching my zeros, but my maximum and minimum have changed. I notice my max is at 2 and my min is at -2. So I have 2 cosine of x or theta. On my next one, I again notice that I have more cycles, so my period has changed. I notice that there's 2, so this is going to be cosine of 2x. I'm again moving to the right, so I know I'm subtracting something. Again, I notice I'm starting at my maximum and going downward, so I'm working with cosine. and I am moving pi over 2 to the right. And finally, I'm noticing that I'm increasing everything by 2. My maximum, though, is at 3. So I know I'm working with cosine, and I am adding 2 at the end. Okay. Those are each individual transformations graphs. You also have the negative option, which I don't have any examples of. So let me create a blank page here just to show you what that might look like. I want you to see it. Okay, so on my original sine, I might have something that looks like this. So this is at pi and this is 2 pi. Okay, if I were to reflect, if I have negative sine of x, my curve simply goes the other direction. It goes down and then up. Okay. Cosine would do the same thing. So if I had cosine, that's my original. Um, let's do red, negative cosine of x. That would mean that I am simply switching my values, my positive and negative. Okay. Start your y's would switch. Okay. All right. Now we're just going to jump right in and do some more complex ones. We have negative 2 cosine of x plus pi plus 3. Find the amplitude, period, midline, phase shift, range, graph a full period, label key points. Let's just go ahead and start by labeling what we know. I'll highlight to save some space. So we have amplitude of 2 and its reflection. We have a phase shift of pi. We have a midline of 3. We have a regular period of 1 per 2 pi. And then we can find the range. Let me get another color here. The range will be k plus or minus a. Okay. All right. I recommend always starting by drawing the original function. I will make an axis here and just labeling just with a dot, just so I have the original, so I know what I'm referencing. That's cosine, so 1, and then, oops, there, and then 1, 2, 3, 1, 2, 3. Okay, that is my original. So it's not in the way. I'll label it up here: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so that's what my horizontal axes are. That's what the cosine function is going to look like. I'm going to do multiple things. I'm going to reflect it, I'm going to stretch it, I'm going to move it upward, and I'm going to move it to the left. So let's take these things one at a time. And I think what I'll do is do this in orange. Whoops. Because the original is in yellow. Okay. So if I am flipping and stretching, I'm going to have a point here. And I'm going to have a point here. And I'm going to have a point here. Okay. I have flipped and stretched. Stretch and reflect. Okay. I will very briefly draw that so you can see it, but I might delete it so it's not messy. Okay. That's what it looks like. Pause here if you need to write that down. All right, now you could go either way. You could move it to the left or move it up 3. I am going to go ahead and move it up 3. So now I'm going to move each of my orange dots up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Oops, I went too far. There it is. Got excited. Okay, now it's going to look really similar to before. I'll go ahead and quickly plot that so you can see how it looks when it's a full curve. Okay. And now the final step is to move it left by a factor of pi. Remember, pi is here. So pi is half of our graph. So that means this guy is moving all the way over to here. Okay. So check how many boxes that is for yourself if you're not quite sure. And then repeat that process. Repeat that process. So now your final curve will be here. Your final curve will be here. Now, if you want to continue it, you can. It would look like that. Right? Notice it no longer even looks flipped because we've made so many changes to it that now it just looks like it got moved up and it stretched. The reflection doesn't even look relevant anymore, but we did reflect. And then let's find k plus or minus a. So we have 3 plus or minus -2. So that means we're going to have 1 to 5. And look at that. That makes sense. Here's a 1 and here's the 5. So after graphing it, we can in fact confirm that that is the case with your midline being here at 3. Okay. All righty. Let's do the next one, 5 sine of 3x minus pi. Start out again, I suggest, by drawing the original. I'll again just use yellow. So start at 0, finish at 0, 0 in the middle, a max at 1, and a minimum of -1. I will again label all those at the top. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that way you can see them as well. All right. Let's go ahead and mark what everything's going to do. So that 5 is going to stretch. That 3 is going to determine the number of periods. And that pi is going to be a horizontal shift. Okay. Okay. Let's start by stretching. A stretch of 5 is going to bring us to 2, 3, 4, 5 maximum, and a -5 for a minimum. Our zeros do not change. Okay, our zeros do not change. Okay, we also have a period change of 3. So remember that equation from earlier. 2 pi over b is your period, which means we have 2 pi over 3. So that means every 2 pi over 3, we complete a cycle. Okay. So now is a good time to recognize where is 2 pi over 3 on the unit circle. You need to know that in order to mark this correctly. Okay, so 2 pi over 3 is roughly here, right? 4 boxes. So you need to do that every 4 boxes. that is going to be where a new cycle starts and stops. Okay, a new cycle will start and stop. So that means, bear with me, in this first cycle, cycle one, we are going to start at 0 and finish at 0. We are going to hit 0 in the middle. We will have a maximum and then a minimum. Okay. So notice I have a very long and skinny sine curve. That sine curve theoretically repeats itself for the other two sections. So we have the second section and the third section. I'm not going to draw them just yet because I don't want to make a mess. Okay. Because we still have the last piece. We still need to shift by pi. We need to shift pi to the right. Okay. So here's the distance that we have to move. So everything needs to move over that distance. So our new starting point, our new maximum, our new 0, our new minimum, and then again, our new 0. So now we are here. Okay. And from there, if you want to continue the cycle, you can. So you'd have a maximum and then back at 0. I would caution you against doing the red one all the way through because then it starts to get really messy. Okay. But that green one is your final curve. That is stretched, repeated, and shifted to the right. Okay. All right. Finally, let's write an equation for this guy. We have a graph that looks like it's a peak at 2 and a minimum of -2, which tells us that our range is from -2 to 2. Okay. That gives you an amplitude of 2 and a vertical shift of 0, right? Because we can tell we haven't moved up or down. Okay. We know that let's see what else we've got. We have, oh yeah, we have a period of 2 pi, right? Because if you look at the distance from here to here, we have 5 pi over 2 minus pi over 2, which is 4 pi over 2 or 2 pi. So that does confirm we don't have any sort of period change. Okay. So in order to write our equation, all we would need to do is say f of x equals, oh, and this is cosine. We don't see a hill and a valley, so we know this is cosine. And the equation does tell us that as well. We have a stretch of -2 cosine x minus pi over 2. Okay. We know it's pi over 2 because originally we would have started here and we have shifted to the right by one little tick mark over there of pi over 2. So that's how we know we are moving pi over 2. Okay. And then finally, write an equation of the form for sine with an amplitude of 4, a period of pi over 6, of phase shift left. So that's going to be a plus, and a midline of y equals -5. So I immediately know that I have a 4 here, a -5 here, a plus pi over 10 here. All I have left to do now is figure out b. Okay. I'm being told my period is pi over 6. So pi over 6 equals the period, which is 2 pi over b. I need to find what b actually is. Okay, so I'm going to go ahead and solve this. So I have 2 pi over 6 equals b, and we have b equals 12. Now I can just write my function. So y, whoops, went way too far. Y equals, I know that there was a 4. I know there's a sine. I now know that I have a 12 x plus pi over 10, close those parentheses, minus 5. Okay, that would be the equation described above. That covers it for section 8.1.